Hello, and thanks for using TickBoom. A student sent through this screenshot and they've asked for help on question 3, and in particular part B and part C. Now what I'll do is I'll work through all 3 parts because this is one of those classic questions where each part builds upon the others that came before it. So working through part A will help with B and then C. The question reads, let z equal cos theta plus I sin theta, so we're in complex number territory. Part A says to use de Moivre's theorem to show that zn plus z to the negative n equals 2 cos n theta. Part B says show that z plus z to the negative 1 all to the 4 is equal to z to the 4 plus z to the negative 4 plus 4z squared plus z to the negative 2 plus 6. And then part C says to hence show that cos to the 4 theta equals 1 on 8 cos 4 theta plus 1 on 2 cos 2 theta plus 3 on 8. So, as I mentioned, I will start with part A. Even though the student didn't have problems with it, I think it's just helpful just for completeness. So, we're told to let z equal cos theta plus I sin theta, a classic complex number definition. Now, z to the n plus z to the minus n, using de Moivre's theorem, we can write that as cos n theta plus I sin n theta plus cos negative n theta plus I sin negative n theta. And all I've done there is take the exponents and put them into the angles. Now, the way we can simplify this is we can make use of the fact that cos is an even function. So cos of negative x equals cos of x. And sine is not even. So sine of negative x would equal negative sine x. So we can make use of these identities to get to the result. So we'll keep the cos n theta plus I sin n theta. But the cos negative n theta we can write as cos n theta. And the I sin negative n theta we can write as negative I sin n theta. So that these two cancel, and then we end up with the 2 cos n theta as required. So that's part A done, fairly simple, but I think just worth working through for completeness. So now we'll get on to the part that the student needed help with. And part B was to show that z plus z to the negative 1 all to the 4 is equal to z to the 4 plus z to the negative 4 plus 4 z squared plus z to the negative 2 plus 6. So that's what we're wanting to show. Now, the first thing we can do is we can note that z plus z to the negative 1 all to the 4 is z plus z to the negative 1 squared times z plus z to the negative 1 squared. So let's just simplify it into the multiplication of two things that are squared. Now, remembering that in general, a plus b squared is equal to a squared plus 2ab plus b squared. So we know that that is how you expand the sum of two things squared. So that means we can say z plus z to the negative 1 squared would be equal to z squared plus 2 times z to the negative 1 plus z to the negative 2, which equals z squared plus z to the negative 2, and then this 2 times z to the negative 1 simplifies to 2 because this is 1. You're effectively adding the exponents, so 1 minus 1 is 0, anything to the power of 0 is 1, so this just becomes 2. So now what we can do is we can insert this result up here and see if when we simplify it all we get to where we need to get to. So therefore, z plus z to the negative 1 all to the 4 is equal to z squared plus z to the negative 2 plus 2 times z squared plus z to the negative 2 plus 2. I've just inserted that result up here. So now I just need to expand. So we'll get z squared times z squared is z to the 4 plus z squared times z to the negative 2 will just be 1 plus 2z squared. Now I'll do this bit. Z squared times, z to the negative 2 times z squared would be 1. Z to the negative 2 times z to the negative 2 would be z to the negative 4 plus 2z to the negative 2. And then finally we'll get 2z squared plus 2z to the negative 2 plus 4. So now if we bring everything together, we'll get our z to the 4 plus z to the negative 4. Then we'll get we've got 2z squared plus 2z squared is 4z squared. And 2z to the negative 2 plus 2z to the negative 2 is 4z to the negative 2. So we get plus 4 of the z squared plus z to the negative 2. And then what we've got left is 1 plus 1 plus 4 is 6. And that's the result we needed. So I think the key to that question was just to break up this power of 4 into 2 powers of 2 and using a simple result that we know from very early math to then expand and kind of simplify. So that's part B. Now we'll move on to part C. I'll just turn over. Part C was asking us to show that cos to the 4 theta was equal to 1 on 8 cos 4 theta plus 1 on 2 cos 2 theta plus 3 on 8. And the word hence in the question makes it very clear we need to use the result we just worked out. So what we can start with is we know that z plus z to the negative 1 all to the power of 4. We can write that using our result from part A as 2 cos 2 cos theta, because our powers here are 1, so it's 2 cos 1 theta. So it's 2 cos theta all to the power of 4. So that's going to be 2 to the power of 4, which would be 2 times 2 is 4, times 2 is 8, times 2 is 16, cos to the 4 theta. Now, if we look at what we just proved here, we've got a z to the 4 plus z to the negative 4. So if we see what that becomes, z to the 4 plus z to the negative 4 would be equal to, using our result from part A, 2 cos 4 theta. And the other thing we have here is a z to the 2 plus z to the negative 2 is equal to 2 cos 2 theta. So now if I insert these results into what we showed in part B, we should then hopefully get the result. So from B, what we showed was z plus z to the negative 1 to the 4 is equal to z to the 4 plus z to the negative 4 plus 4z squared plus z to the negative 2 plus 6. Therefore, 16 cos to the 4 theta is equal to 2 cos 4 theta plus 4 times 2 cos 2 theta plus 6. So if I divide everything by 16, we'd get cos to the 4 theta equals 2 on 16, which is 1 on 8, cos 4 theta, plus 4 times 2 is 8 on 16 is 1 on 2, cos 2 theta, plus 6 on 16. I can divide each by 2 and I'd get 3 on 8. And that's the result. So there you see, once we had shown part B, part C becomes quite simple because all we're doing is inserting the results from part A and then taking those and inserting the result from part B, and we get what we were asked to prove. So hopefully that was all clear. I think once you have that kind of creative moment of getting the power of 4 into 2 powers of 2, everything kind of falls out quite neatly from there. So I think that was the key to thinking about this question. So hopefully you found all that helpful, and tick boom.